All right, so we're going to look at number 11. So each of these problems tells you to revolve around a different axis. So we're just going to have to remember that things that are vertical, if we're revolving, sorry, horizontal, anything horizontal that we're revolving around is going to be in terms of x. Anything vertical that we're revolving around is going to be in terms of y. Okay, and we're remembering, since this is the washer method, we have pi big R squared minus pi little r squared. Okay, so for this one, I'm going to go ahead and draw my picture. I have x squared, looks like that, and then I'm going to show you the x to the third graph. Actually, I might make this even smaller. I just want to show you guys because it can be hard to, based off memory, we know what it looks like, but to know which one goes left and right and up and down and that sort of thing can be a little bit iffy on this. So x to the third is underneath it, and then it switches over. And if I make this graph even smaller, I can see it a lot better. So there's our parabola, and there's the cubic. So it comes from underneath, and then it crosses it at 1. So it's going to come from underneath, and then I over-exaggerated it really badly, but you get the idea. So x equals 0, x equals 1. We are revolving it around the x-axis, so this is our axis of revolution right there. We're going around the x-axis. So my integral is going to be from 0 to 1. I have pi big R squared minus pi little r squared dx. So my big R is going to be top minus bottom, and it's going to be the curve that is furthest from the axis of revolution to the axis of revolution in this case. Sometimes that will switch. So the curve that's furthest is going to be the x squared, and then we're going to do x squared minus 0, so top minus bottom, and then the curve that's closest to the axis of revolution is going to be x to the third. So x to the third minus 0. So I have pi of x squared squared minus pi x to the third squared. Now, if I'm typing this in my calculator, I would probably type it like that. If it's a multiple choice question, they would most likely pull out that pi and call this x squared squared minus x cubed squared dx. So I just want to show you guys that so that if you were doing a calculator inactive problem and just setting it up, that's probably how they would write it. So I'll leave that one for you guys to plug into your calculator. I also wanted to show you problem 14 because this one is going around a horizontal line, so this one's going to be, actually this one's also in terms of x. I'm going to do a vertical line though as well. So we have the parabola y equals x squared. And this one, since it's calculator active, we can go ahead and graph this one on a calculator if we want. So 4x minus x squared. I know that this, if I was to factor it, would be x times 4 minus x. So I know it's going to have an x-intercept at 0 and positive 4. It's a negative x squared, so I know it's upside down. So there's our regular parabola. There's our upside down parabola. I can see where these cross by using my intersection. So I'm pretty sure it's at 0, but I could, there we go, it's at 0. And the other intersection is at 2. So I know that my integral is going to be from 0 to 2. And it says the line y equals 6. And I can graph this one, so I'm going to go ahead and do that. Can't graph my vertical lines, but I can graph my horizontal lines. So the axis that we're revolving it around, the axis of revolution, is actually up here. So I wanted to show you guys this one so you could see what happens if the axis of revolution is actually above what you're doing. Okay, so we have pi r squared minus pi r squared dx. And we look at the curve that is furthest from the axis, and so that's going to be this one right here. And we do top minus bottom. And this time when we do top minus bottom, we're going to be doing the axis of revolution minus the curve. So it's going to be 6 minus x squared. And then the other one is going to be 6 minus the curve that's closer to it. So 6 minus 4x minus x squared. That's terrible to read, sorry. So they would probably take the pi's out. You can leave them in if you're just typing it in, but just so that we get the practice. All right, and I'll let you guys type that in. And then I also wanted to show you number 16. This one actually has a vertical line, so this is going to be in terms of the y's this time. So x to the third looks like this. X equals 0. Nope, is a vertical line. Just kidding. X equals 0 is this line right here. And then y equals 8 is a horizontal line up here. And so that means that this right here is our area. And this would be y equals 0. Up here is y equals 8. The vertical line x equals 2. I know that 2 to the third equals 8, so I actually know that this point had an x value of 2 right there. And so that means that this right here is the axis of revolution. That's what we're rotating around. So my interval is from 0 to 4. I wrote y equals 0. Y equals 8. Okay. 0 to 8. And we have pi r squared minus pi r squared dy. And so I'm going to start off by looking at the curve that is furthest from the axis of rotation or axis of revolution. And the curve that's furthest is that vertical line at y equals 0. So I'm going to do right minus left, so I have 2 minus 0. And then for this one, my curve that's closest is that x to the third line, so I'm going to do 2 minus this curve in terms of y. So x equals the third root of y, so I have 2 minus the third root of y. So we have 2 squared minus 2 minus third root of y squared dy.